Hi, I'm Jason Burrows, Senior Storage Solutions Engineer at Micron Technology. Today we'll be continuing our dive into virtualization with VMware VSAN utilizing Micron's All Flash storage. We'll also take you through managing vSAN using the Vsphere web client. In the previous video, we explored the Vsphere web client and began to configure our All Flash VSAN. In this video, we'll cover storage policy-based management and thick provisioning, as well as demonstrating how Micron's All Flash VSAN holds up to a synthetic workload. Let's take a quick look at storage policy-based management, which is how data is protected with vSAN. Up here at the top, we'll click on Home, Policies and Profiles, and then VM storage policies. A policy is, in short, how many copies of the data, how many devices that copy is striped across, and a few other parameters. The default policy for all storage is 2 copies of the data, which VMware refers to as FTT equals 1. FTT means failures to tolerate and could be a drive, network interface, or entire node. This means with FTT equals 1, you can tolerate 1 failure. Now here, you can see that default policy. Let's create a new one. Click on the New icon to create a new one. Let's make it FTT2 and stripe width to 2. This means that every object will be striped across 2 disks, which may be on the same server or another server. See, these stripes are not actually for data protection, but they're for performance. Many people stick with the default of 1, which is no striping, but after performance testing, you might decide you want to change that value. So here we're going to create a rule set, which is part of the policy. We're going to base those rules on vSAN. See, we're going to add a rule for number of disk stripes. We're going to change that to 2. Then we're going to add another rule, which is the number of failures to tolerate. We're going to leave that at 1. We can set a few other things, which I show here. These other 3 options that we haven't already configured. The first one is Flash Read Cache Reservation. This is an option that's relevant and important in a hybrid vSAN configuration, but in an all-flash configuration, it's actually not used at all. We'd like to get VMware to remove this from a future version. Forced provisioning allows the system to provision an object using this policy even if all the resources aren't available. The idea there is if you're trying to test something in a lab and you don't have enough space for 2 or 3 or 4 or 10 copies, it will go ahead and create the virtual machine. Finally, object space reservation is thick provisioning. Object space reservation is just what VMware decided to call it. We'll say next. It will configure that, and it will actually show you which data stores are compatible with that rule set. And there's where we would complete it. And here you can see our new policy was created. So let's go back and look a little deeper at the configuration of our lab systems. You can see here we've got our 4 vSAN nodes. In addition, here are all of our virtual machines. In addition to a few odds and ends, we have 20 CentOS 7 Linux hosts running workload generation software. We also have a remote desktop session into a Windows virtual machine, which manages those 20 Linux virtual machines. Here you can see the software called Diameter, which has been in use for over a decade for performance testing. This is a synthetic workload. It's using 70% read, 30% write, 4K random IOPS. In that workload, which is a very typical enterprise workload, you can see that we're getting 455,000 IOPS across 4 nodes. This is 1.8 gigabytes per second total throughput at less than 1 millisecond response time. These are fantastic results. In fact, it's really interesting to look at VMware's own guidance. As you can see here, in the all-flash configuration, the highest performing version, they expect you to get up to 80,000 IOPS per node. We're actually getting 110,000 IOPS per node. And as you look further, their systems have more RAM, their systems have more drives, including more cache drives, substantially more expensive. Our configuration gets us well over their threshold with less hardware, so we're doing good. I hope you're just as excited as we are about deploying an all-flash vSAN. To learn more, follow us on Twitter at Micron Storage or connect with us on LinkedIn. For new articles, blogs, and videos, visit us at micron.com/virtualization.